Hello students, welcome to the 20th lecture of Engineering Chemistry. We are learning the organic reaction mechanism of Unit 5. I hope and wish that all of you are fine and focused on your studies through e-learning process. So let us continue our e-lecture series with lecture 20. Before starting the today's lecture, let's have the quick recap of the lecture 19. Yesterday we have learned about the substitution reactions, in which nucleophilic substitution reactions are discussed in detail, and SN mechanism, stereochemistry and the comparison between SN1 and SN2 reactions were studied in the detail. Then we have started with the substitution nucleophilic intramolecular reaction, that is SNI reactions, and after that aromatic substitution nucleophilic reactions are completed, that is SNAR reaction. After that we have learned about the electrophilic substitution reactions, in which electrophilic aromatic substitution as well as the electrophilic aliphatic substitution reactions we have discussed, and we have learned that the electrophilic substitution reactions are the characteristic reactions for the aromatic compounds. Then we have learned about the mechanism of the free radical substitution reactions that we have discussed in the lecture 19. Now in today's lecture we are going to learn about the elimination reaction in detail. What are the elimination reactions? The elimination reactions involves the loss of atoms or the groups from the molecule, and this loss of molecules or atoms results in the formation of the double bond in the molecule. So basically the reactions or the elimination reactions are those in which, due to the elimination of the two atoms from the parent molecule, that is the substrate molecule, formation of the double bond takes place in the product, that is formation of the alkene takes place. Now types of the elimination reactions. Depending upon the position of the leaving group, that means the groups which are eliminated from the parent molecule or the substrate molecule, so depending upon the position of the two atoms or the leaving groups, the elimination reactions are classified as alpha elimination reactions, beta elimination reactions and the gamma elimination reactions. What is alpha elimination reactions? The alpha elimination reactions are those in which two atoms or groups are eliminated from the same carbon atom. Look at this structure here. In this, hydrogen and halogen or the X group are situated on the same carbon atom. Therefore, in this type of elimination reaction, both the leaving group are attached on the same carbon atom and eliminated from this. This results in the formation of the carbene. This is also called the 1-1 elimination. Why it is called the 1-1 elimination? Because both the leaving groups or the eliminating groups are situated at the same carbon atom. Hence, elimination takes place through the only single one carbon atom. That's why it is called the 1-1 elimination reactions. Second kind of elimination reaction is the beta elimination or the 1-2 elimination reaction. These are the most common elimination reactions in which two atoms or groups are eliminated from the adjacent carbon atom. For example, this is the first carbon atom, consider, and this is the second carbon atom. Since the substituent group here, so we denoted this carbon as the first carbon atom. So the elimination from the first and second carbon atom, adjacent carbon atom takes place. That's why it is called the 1,2 elimination or the beta elimination. Why it is called beta? Because this is the carbon atom which is having the functional group X, so it is the alpha carbon atom, while the adjacent carbon atom from the alpha carbon atom is the beta carbon atom. So why it is called the beta elimination? Because this includes the elimination from the alpha and the beta carbon atom. That's why it is called the beta elimination or the 1,2 elimination. Same, this results in the formation of the alkene. Now, the third category is the gamma elimination or the 1,3 elimination reaction. As indicated by the name, it is the 1,3 elimination. That means the eliminating groups are present at the first and the third carbon atom, 1 and 3rd position. That's why it is called the 1,3 elimination. And why it is called the gamma elimination? Because look at the position. This is the alpha carbon atom, this is the beta carbon atom, and this is the gamma carbon atom. So the eliminating group are situated at the first and the third position. That means alpha and the gamma position. That's why it is called the gamma elimination. Look at this structure here. If the eliminating groups are from first and third carbon atom, that means the valency after the elimination is get free from the first carbon atom and the third carbon atom. So there should be the bond formation between the first and the third carbon atom. This bond formation should be taken place. So in the gamma elimination or in the 1,3 elimination reaction, the formation of the tricyclic compound takes place. Why tricyclic compounds? Because first and third carbon atom bonded together. So these kind of reaction resulted in the cyclic product, while in the previous two reactions there is the formation of the unsaturated compound. In the first compound there is the first reaction, that is the alpha elimination, formation of the carbene or nitrene takes place because the elimination from the same carbon atom occurs, while in beta elimination there is the formation of the unsaturated compound, alkene is formed, and in gamma elimination there is the formation of the cyclic compounds, as here tricyclic compound is formed. So this is the 1,3 elimination reaction. Among all these three reactions, that is alpha, beta and gamma elimination reaction, the beta elimination reactions are the most common elimination reaction. Hence, now we are going to discuss beta elimination reactions in detail. As we have learned just now that beta eliminations are the 1,2 elimination in which the atoms or groups are eliminated from the first and the second carbon atom, or we can say the atoms are eliminated from the adjacent carbon atom. So this kind of reactions are the beta elimination reaction. Depending upon the mechanism of the elimination, the beta elimination reactions are further divided in the three categories, that is elimination unimolecular reaction, E1 reactions. Second, elimination bimolecular reactions, that is E2 reaction. Third, elimination unimolecular conjugate base reaction, that is E1CB reaction. So beta eliminations are the 1,2 elimination reaction. Depending upon the mechanism of the elimination, these beta elimination or 1,2 elimination reactions are of three types, that is E1 reaction, E2 reaction and the E1CB reaction. Now let us start with the elimination unimolecular reaction, that is the E1 reaction. Elimination unimolecular reaction, by the name we can understand that in the rate determining step of this reaction only one molecule is taking part. The the kinetics of this reaction is the first order kinetics. That means in the rate determining step only the one molecule is taking part. So the elimination unimolecular reactions are those which takes place through the two-step process, and in the first step, formation of the carbocation takes place. For example, elimination of the tertiary haloalkanes. This is the best example to study the even kind of reaction. So, as we have discussed just now, that the even reactions are taking place in two-step process. First step is the generation of the carbocation intermediate. This is the butyl chloride. In the first step, this chloride is removed as Cl minus. This is the slow step. Since this is the slow step, therefore it is called as the rate determining step. Due to the removal of the Cl minus or the elimination of the Cl minus, formation of the carbocation intermediate takes place. So, since this is the rate determining step, and in the rate determining step only the substrate molecule is taking part. So, the rate of reaction depends only on the concentration of the substrate molecule. Therefore, it is called as the unimolecular reaction. So, this is the first step of this reaction. What is the first step? This is the formation of the carbocation intermediate. Now, the second step is the deprotonation of this carbocation. Deprotonation means removal of the proton from this carbocation. Removal of proton or deprotonation results in the formation of the double bond. For this deprotonation, the basis or the solvent molecule helps. The solvent molecule abstracts this hydrogen like this. The hydrogen removes and the electrons of this bond moves towards this carbon atom, which results in the formation of the double bond. So butene is formed with the loss of the proton. That's why it is called the deprotonation step. This is the first step. So we can summarize the even reaction or elimination unimolecular reaction in two steps. First is the formation of the carbocation. This is the slow step. Hence, this is the rate determining step. And since in this step only the one molecule is taking part, so this follows the first order kinetics. In the second step, deprotonation of the carbocation takes place, which results in the formation of the alkene or the product. Now, question comes in the mind that what happened when alkyl halide have two or more than two different kind of beta carbon atom. What are the beta carbon atom here? Since chlorine is attached to this carbon atom, so this is the alpha carbon atom. This is the alpha carbon atom. Now, beta carbon atom is this and this. In this example, all the beta carbon atom are the methyl carbon atom. So, all the beta carbon atom are equal and all these carbon atom results in the formation of the same kind of alkene, that is the 1-butene is formed. But what happened when this beta carbon atom has another group? Say like it may be possible that it may be of ethyl group, it may be of propyl group. So what happened when different kind of beta carbon atom present in the parent molecule of the substrate molecule? Then the answer we can obtain from the Sedzeff rule. If the alkyl halide have two or more different kind of beta carbon atom, then the major product of this beta elimination reaction is the more stable alkene. And what is the more stable alkene? The alkene which has the more substituted double bonds is called the stable alkene. More substituted double bond means the alkene in which double bond has the higher number of substituent groups. This is called the Sedzeff rule. In other words, we can say that alkene with the less number of hydrogen on the double bond. Less number of hydrogen on the double bond means more number of the substituent group on the double bond. So, if the if the alkyl halide has the more than two different kind of beta carbon atom, then to predict the major product the Setzeff rule is applied, and according to Setzeff rule, the product will be the more substituted alkene. That means in which the double bond having the less number of hydrogen is the favorable product or the major product. Let us understand with this example here. This is the secondary butyl chloride, in which this carbon atom is the alpha carbon atom and this is the beta carbon atom and this is also the beta carbon atom. Clear? Now, first step is the same, that is the carbocation formation. Second is the elimination of the proton or the deprotonation reaction. So this proton can be abstracted from here or can be abstracted from here. Both of these carbon atom are the beta carbon atom. So now what happened? Look here, that if the hydrogen or the proton is eliminated from here, then double bond is formed between these carbon atom. To understand the concept, we shall give the numbers of these carbon atom. Okay. Now, if we are considering this carbon atom as the beta carbon atom, then the double bond is formed in between second and third carbon atom and formation of the 1-butene takes place. While if beta carbon atom is considering we are this, then the elimination from H is from this carbon atom, first carbon atom, and there is the double bond formation between the first and second carbon atom and formation of the 2-butene takes place. Now, what is the major product and why? Why it is so? According to Setzeff rule, the major product is that alkene in which the double bond has the higher number of the substituted group and lesser number of the hydrogen. Clear? Now, this double bond has these two substituted group, 1-methyl and the second methyl and 2 hydrogen. Clear? Now, look at this structure here, 1-butene. In this structure, double bond is having only the 1 alkyl group as a substituent group. So, here the substituent group are the 1 and the hydrogen at the double bond are the 3. So, according to Setzeff rule, the product formed in this kind of reaction is that kind of alkene in which the double bond having the more alkyl group here, 2-methyl group is present and the 2 hydrogen is present at the double bond. While in this alkyl group present is only 1 while hydrogen present is 3. So comparing this, less number of hydrogen were present at this compound, less number of hydrogen is present, more substituent group are present in 2-butene. So according to Setzeff rule, this product is the major product or preferably from the 2-butene in this reaction. Now question comes that why this kind of alkenes are more stable? Because of the more hyperconjugation due to the more substituted alkyl groups, these type of alkenes are more stable. So according to Setzeff rule, when an alkyl halide having the different type of beta carbon atom, then the elimination should takes place in such a manner that more substituted alkene is formed. I hope you must have understood this concept here. Now it is time to check your learning. Look at this reaction here. Which is the main product of the following reaction? This is the kind of elimination reaction, 1,2 elimination reaction. In this reaction, this is the alpha carbon atom and beta carbon atom may be this beta, maybe this beta. So which would be the major product in this reaction? Think about this question. Yes, you got the right answer. That is the C. Why C is here? Because in this product, according to Sedzev rule, in this product, this double bond has the 3 substituent group. So it is the major product. This cannot be formed because in this the double bond has only the one alkyl group as a substituent group. That's why it is not formed. Now the next topic is the factors affecting elimination unimolecular reaction, that is the even reaction. There are the main two factors which affects the even reaction. First is the nature of the substrate. The rate of an even reaction increases as the number of R group on the carbon atom which is having the leaving group increases. Why it is so? Because as the number of R group is increases on the carbon atom which is having the leaving group, that means it forms the more stable carbocation. See here, this is the tertiary halide which results in the formation of the tertiary carbocation in the first step. This results in the formation of the secondary carbocation in first step, and this result in the formation of the primary carbocation in the first step. And we know the tertiary carbocation is the most stable among three. That's why it shows the maximum reaction. So the order of the rate of reaction is that for the even reaction is tertiary halides give the maximum rate of reaction, while it is medium for the secondary halide and least in the primary halides. Second important factor is the nature of the base and the solvent present. Weak bases like H2O and the alcohol favors the even reaction. Why it is so? Because these weak bases can stabilizes the carbocation intermediate. That's why we can conclude now that tertiary halide with the presence of the weak bases are the most favorable reaction for this type of reactions. Now if you remember the SN1 reaction, similar kind of conditions are also in the SN1 reaction. That is, SN1 reactions are also favored by the presence of the weak bases and the protic solvents, and for the tertiary halide it is the it shows the maximum rate of reaction. Same kind of conditions are suitable for the even reaction. So similarities are for SN1 and even reaction are that both of these follows the first order kinetics. In the first step, in both of these type of reaction, first step is the formation of the carbocation, which is the slow step, hence the rate determining step, and hence in the rate determining step only one molecule is taking part. That's why both of these reaction follows the first order kinetics. And first step in both of reaction is the same, that is the formation of the carbocation, and both these reactions are favored by the protic and the polar solvent. Now what is the difference then? The second step is different in both of the reaction. That means in first step in both reactions carbocation formation is there. In the next step, what is the feature of this carbocation decides the reaction is the SN1 reaction or reaction is the even reaction. That means if in the second step nucleophile attacks on the carbocation, then product is the addition product. That means nucleophile adds on the carbocation, so this results in the SN1 reaction. While if in the second step proton is eliminated with the help of base, that means formation of the double bond in the parent compound takes place and formation of alkene results. So if the carbocation undergoes with the addition of the nucleophile, then it results in the SN1 reaction, and if carbocation undergoes in deprotonation, then it undergoes in the even reaction. Since in both reactions the rate determining steps are the same, that is the formation of the carbocation, so they cannot be individually controlled because first step is the same in this reaction. And because even reactions often occur with the competing SN1 reaction, the even reactions of alkyl halide are much less useful than the E2 reaction, because all the conditions are same for SN1 reaction and the even reaction. The bases we use in the reactions are the same. So it is the probability for these kind of reaction that there is the competition between the SN1 and the even reaction. So final product will be the mixture of both of these reactions. So sometime the substituted product is formed and alkene is also formed in the reaction. So we cannot isolate properly one kind of product, that means if we cannot find out the only the alkene as a product of this kind of reaction, there will be the substituted product is also formed in this kind of reactions. Now let us summarize what we have learned today. Today we have started with the elimination reactions, in which we have learned the definition of the elimination reactions and the types of elimination reaction, in which we have learned the alpha elimination, beta elimination and the gamma elimination. We have learned that the alpha elimination are the 1-1 elimination reactions in which both the atoms are eliminated from the same carbon atom, and these results in the formation of the carbene and the nitrene. While the beta eliminations are the reactions in which elimination of two atoms is from the adjacent carbon atom, that's why it is called the beta elimination reaction. These kind of reaction results in the formation of the alkenes. And gamma eliminations are those in which elimination of two atoms are from the first and third carbon atom. So these gamma elimination reaction results in the tricyclic compound formation. Among all these three reactions, we have learned about the beta elimination reaction in detail. The beta elimination are the 1-2 elimination reaction, and depending upon the mechanism of the elimination, these elimination are of three types. Elimination unimolecular E1 reactions, elimination bimolecular E2 reaction, and elimination unimolecular conjugate base E1CB reactions. After that, we have learned in detail about the even kind of reaction. We have learned the detailed mechanism of the even reaction, that even reactions are taking place in two steps. In the first step, carbocation formation is there, and in the second step, deprotonation of the carbocation takes place. Then we have learned about the Sedzev rule. According to Sedzev rule, if an alkyl halide is having the more kind of beta carbon atom, then which alkene is formed? So according to Sedzev rule, the alkene having the more substituent group on the double bond is formed as the major product. Then we have learned the factors affecting the E1 reaction and comparison between E1 and the S1, that is the nucleophilic substitution unimolecular reaction we have discussed. That's all about the today's lecture. Thank you. Take good care of yourself and stay safe and healthy at home. Thank you.